Good evening, everyone. A very warm welcome to our students, teachers, parents, judges, and everyone joining us online. Welcome to the grand finale of Chavara Public School's How and Why Budding Technologist 2026 to 27. Today is a celebration of curiosity, creativity, and technology. After 2 months of learning, researching, and building, our young innovators are finally ready to showcase their ideas. And before we begin this exciting journey, I would like to invite my friend Seraphin for the prayer.
Let us take a deep breath together, quiet our minds, and bow our heads for the prayer. Heavenly Father, Almighty God, we welcome your peace and your presence here today. We thank you for bringing us together in this moment of a golden opportunity. You are the author of wisdom, the giver of talents, and the source of all creative vision. We ask that you bless this event and everyone gathered here from start to finish. Lord, let us come against anxiety, fear, and self doubt right now. We know that nerves can make our hearts race and our minds feel cluttered. As voices are lifted today, let the words flow smoothly, naturally, and with great power. Lord, please give everyone a steady breath, a confident tone, and a perfect timing. Amen.
Thank you, Sarafan, for the prayer. This year, our students explored fascinating areas of technology and innovation, from drones and biotechnology to AI, robotics, and more. 11 teams have made it to the grand finale, and over the next 2 days, you will see their ideas come alive. Let's take a quick look at their journey so far.
A big thank you to the school management, principal, teachers, coordinators, and our mentors who made this journey possible. And now, let's cheer for the stars of the evening, our budding technologists.
Today, our projects will be evaluated on research, technical understanding, innovation, presentation, and the ability to answer questions confidently. We now have the honor of inviting our first esteemed judge, Dr. Tatiana Surasova, an IEEE STEM champion and the organizer of the RoboSkills International Robotics Competition. Her expertise and contribution to STEM and robotics education make her a wonderful addition to our event. Ma'am, thank you for joining us and we welcome you to our event.
Uh, I glad to see you all. It's very I I like that very many girls in these competitions. It's very wonderful because when I started my teaching, it's technologies. It's somebody says that technologies is only for men and for boys, and now we see that all many girls try and work in this in the STEM competitions, took part in the STEM competitions and make projects. I very glad to see you there in this competition. Thank you for inviting me.
Thank you, ma'am. And now let's welcome our second judge. Ms. Farah Khan is a science subject leader, STEAM lead, and STEM ambassador UK. With a strong passion for science, technology, and innovative education, She's also a fellow of the Chartered College of Teaching and actively contributes to mentoring and developing the next generation of learners. Ma'am, thank you for joining us and we welcome you to our event.
Well, thank you for welcoming me and for this very kind introduction. It's a real pleasure to be here with you all today. I am super excited to see your project presentations that you have prepared. Mr. Ajaysa has been telling me so much wonderful stuff about all your efforts and achievements over the course of your project work. I'm looking forward to hearing your ideas. I'm looking forward to hearing what's inspired them and what you've learnt along the way. But most importantly, I want you to relax and have fun as you present. You have nothing to worry about. You are all winners just being here today and presenting today. And I'm really looking forward to talking with all of you today. Good luck, everyone.
Thank you, ma'am.
A very warm welcome to our beloved principal for the Chavara CMI. He is a committed and visionary educational leader with a strong background in human resource management, psychology, and education. His diverse academic expertise enables him to understand both the institutional and human aspects of education. Thank you so much for joining us, Father. We welcome you to this event.
A warm welcome as well as to our director, Father Joby Alexiami, director and finance administrator. He is a dedicated educational leader who combines an academic expertise with strong administrative and financial management skills. With qualification in biotechnology and education, he brings a unique blend of scientific knowledge, teaching experience, and an institutional leadership. We welcome you, Father, to this event.
Now, a warm welcome to our Vice Principal and Rector, Father Paul St. Joseph CMI. He is a dedicated academic leader with a strong background in commerce and education. His experience and commitment to student development enables him to contribute meaningfully to both the academic and administrative life of the institution. We welcome you to this event, Father.
A warm welcome to our headmaster, Tom Pijosa. He is a dedicated and experienced educator committed to academic excellence and overall development of students. With a strong academic background in science and education, he brings knowledge, experience, and a student-centered approach to school leadership. Thank you for joining us today, sir. Also, we would like to welcome other management members, coordinators, teachers, parents, and our dear friends. Let's get into the much awaited project presentations. Over to you, Lakshmi.
Thank you, Zephania. Let's get started. Our first team takes us into the world of drone technology. From capturing images to helping in agriculture, disaster management, and delivery, drone technology is changing the way we look at the world. Let's see what our young innovators have discovered about this fascinating technology. Please welcome Aaron Meritoni, Hannah Suryak, and Darshita Spillai of grade 6 presenting the drone technology.
A very good evening to our respected judges. Today, we will be presenting the topic drone technology. Drones have this experience the sky like never before. I'm Aaron, and here with me are
Darshit, and I'm Hannah.
So before we begin, let's see what we're talking about. I hope that video gives us more understanding on what we are presenting. So what is the first purpose of drones when they were invented?
Drones were actually invented by the military during the First World War to serve as expandable pilot aerial targets, short-range anti-aircraft gunners.
Military drones today. Military drones have evolved a lot from their first form. They're being widely used in all the wars. Some famous military drones are the MQ-1 Predator and also the MQ-9 Reaper. Now, let's compare the different types of drones. First, we have the single rotor drone, also known as the monocopter. It only uses one rotor. It has the shape of a helicopter, often used in heavy load lifting. Then we have the quadcopter. which is the most commonly and widely seen one. They use four rotors. They are more stable than single rotors as their sides are balanced. They are used for photography, videography, racing, and even for hobbies. Then we have the hexacopter. Hexacopters use six rotors. They are capable of carrying bigger cameras. Then we have bicopters which use two rotors, tricopters with three rotors, and also octocopters with eight rotors. Drones with 10 rotors are known as the dodecacopters, and with 12, they are known as the decacopters. The dodecacopters are only used in the industrial field. Why use single rotor drones for heavy loads instead of multi rotors?
Even though multi-rotor drones seem more stable, the special design of the single rotor allow it to carry heavy loads. Who is known as the father of drone technology? Is widely recognized as the father of drone technology, even though the first drone was not invented by him.
Now let's see the prototype. This prototype shows a quadcopter which uses four rotors and propellers. The propellers are mounted onto the rotors, which allows the drone to fly up and hover. This prototype contains a camera for taking photos and videos. This is a drone mainly used for hobbies.
So, how do a drone actually work? Drone work using four main forces: thrust, lift, weight, and rotors. Rotors spin very fast. This creates lift, which pushes the drone up into the air. Thrust, what moves the drone forward, backward, or side to side. When thrust, lift, weight, rotors all work together, the drones can fly off, hover, and fly very smoothly. That is basically the science behind how do a drone stay in air. Key components of average drone: motors and propellers, airframe, GPS module, sensors, and battery. But different drones may use different components according to their purpose.
Drones use GPS for precise positioning, ultrasonic sensors help detect obstacles, and IMU and gyroscopes ensure flight stability.
So here are some of the sensors that are used in a drone. Now let's see the great evolution of drones. Drones have evolved a lot during the past decades. It all began in the World War One, when drones were simple and mechanical. They were used to train anti-aircraft gunners. Then in the World War Two, drones were actual parts of missions, not just practice. Then in the Vietnam War, we saw a huge jump. Drones were actually looking like planes. They were used for surveillance and spying without putting human lives in danger. Then the 70s, 80s, and the 90s. Overall, drones became smarter, more efficient, and had a longer flight time. Then commercial drones. These are when drones were available to the public, not just the military. Companies started using them for commercial purposes. Then drones today. Drones have become a huge part of our life, not just flying robots. Now let's see the applications of drones in our lives today. Drones are stepping into the fields of agriculture, helping farmers monitor crops, medical and package delivery, delivering lab samples, search and rescue missions, providing aerial view, infrastructure inspection, inspecting high voltage areas, media and entertainment, being a great hobby, environment conservation, inspecting wildlife without harming or disturbing them.
Drones are revolutionizing our world, from monitoring crops and vital infrastructure to delivering packages right to your doorstep, and even saving lives in search and rescue missions.
So here are some of the examples in action. Now let's discuss the future scopes of drones. AI autonomy. Drones will soon fly using AI, not human control. Swarm intelligence. Hundreds and thousands of drones coordinating on their own. Next gen batteries and fuel cells. It means drones will have a longer flight time in the future. Automated cargo delivery. Drones will soon deliver parcels to your homes. Then we have passenger drones. Imagine flying across a city to avoid traffic.
AI autonomy drives flight. Swarms coordinate missiles extend range. Cargo drones deliver. Passenger drones are next.
So that was some of our future innovations. Now let's see the Guinness World Records held by drones. The fastest drone ever is the Peregrine V4, the most simultaneous drone show or drone flight. This record goes to China for a drone show that involved 33,615 drones.
Now, sky's not the limit, it is just the beginning. Thank you, everyone.
So that brings us to the end of today's presentation. Once again, thank you to one and all for hearing us. So now you're welcome for any questions that you may have.
That was an exciting look into the world of drones. Well done, team, for taking us through your research and ideas. Now, let's hear from our judges. We invite them to share their questions and thoughts on the presentation. Over to you, Faraman.
Thank you. What a wonderful presentation. So impressive. I think you've set such a high bar for the rest of the groups who are presenting after you. So everybody else will have to up their game. You've done brilliantly for your first presentation, and I believe you're only in grade 6. So you have really done extraordinarily well. Commendable. Well done. I really liked your understanding about the topic. It's clearly something that has interested you, and you've gone to such great efforts to research it and find out about different types of drones and also their uses and applications. That's wonderful. And you all took part in speaking, so really good teamwork. Very well done. You should be very proud of your efforts today. You showed your prototype model very briefly. Just my first question for you, I've got 2 questions only, but my first question for you is, could you tell me a bit more about your prototype? I'm very interested to hear.
Ma'am, should I show the prototype with it? Should I show the prototype when I'm saying
Yeah,
about
and explain it maybe, like what you did to design it, what are the sensors looking at, what is the drone going to be used for?
So this is a quadcopter which uses 4 rotors and propellers. So the main sensor in it is the IMU chip, which contains the gyroscope, accelerometers, and barometers. So these blades are the propellers, and they're mounted into a rotor inside. So when both of them work together, these propellers will spin at a high speed. This makes the drone fly up in the air. And in the difference of speed, while the rotor spin can change the direction of it. And the rotor spin in counterclockwise according to the opposite direction. So while the front rotor spin in clockwise, the back ones will spin in counterclockwise.
Wow.
And this also contains a camera for videos and photos.
Wow, that is so impressive. And you all came up with this together?
Yeah.
Fantastic. Well, my second question to you, you've gone through the list of all the different uses for drones. There's so many, but if you could choose your one priority use, one that each of you thinks, if I had a drone, I would use this for this particular thing. Could each of you answer that question for me? What would you use a drone for?
So in case of me, I really don't think I would be using it as a part of my daily life, but maybe as a hobby.
As a hobby to fly and practice. And what about you, Hannah?
Yeah, for photography and video taking for like racing and
Oh, you know, there are drone races that happen. You could enter your drone. That will be good. And what about you, Darshit?
I am using it as my hobbies, like flying it on.
Okay, so you would basically use your drone for your leisure and your enjoyment. That's fantastic. Are you interested in pursuing drone technology further in the future?
Yes.
Lovely. Well, I'm very proud. Thank you very much, all of you.
Thank you. Thank you, ma'am.
I have questions too. Who was programmer in your team? Uh-huh. Okay. And what programming language do you used?
It is basically easy. I just inserted it. It was pre-done. So I just had to put it together. That's all.
Okay. Thank you. And you show many type of drones, but what you think about vertical or horizontal propellers? Same drones which use horizontal propellers and vertical propellers.
Ma'am, could you repeat the question?
What's the difference for you?
Ma'am, I could not understand the question. Could you please repeat it?
Mhm. Okay. In your drones, you have 4
Yeah.
horizontal propellers. Is it?
Yeah.
Yes. And why you did not make drones with one vertical propellers? Why you choose this construction?
Because it helps the drone take off in a less, like, when it's a small speed, it allows it to go on vertically up in the air instead of using like a runway for aircrafts.
Okay. Thank you. I have no questions.
Next MC, please continue.
Thank you, judges, for your valuable questions and feedback. And once again, a big round of applause for young innovators. Now we have something amazing for the YouTube viewers. To announce it, I welcome Sriya. Over to you, Sriya.
Hey, it's time to get our YouTube audience into the action. Across these 2 days, we will have 6 exciting quiz questions, and the winner will be selected from those who answer all 6 questions correctly. You can participate by scanning the QR code on your screen or by clicking the link shared in the chat box. And you have a maximum of 1 minute to submit your answer. So guys, get ready, keep your phones handy, and let's see who gets this one right. Here comes the first question on the screen. So the first question is, which device is used to detect the orientation of a robot or smartphone? Remember guys, this question is exclusive to our viewers, so viewers, it's your time to shine. Now for those of you who have the right answer, be sure to submit your answers because an exciting prize is waiting for you. I repeat the question. Which device is used to detect the orientation of a robot or smartphone? So time's ticking. Be fast, guys. That's a short amount of time. Okay, time's up. Keep watching. We'll reveal the winners later. Now let's get back into the project presentations. Over to you, Safania.
Let's continue our journey of innovation. Our next team takes us into the exciting world of aeromodeling. From designing miniature aircraft to understanding the principles of flight, aeromodeling blends creativity with engineering precision. Please welcome Michael Roby, Aniket S. Nair, and Ivan Biju of Grade 7 presenting aeromodeling.
You're unmute. You're mute.
Aniket, you're muted.
Good evening, everyone. Today, me and my friends are going to present on a very interesting topic known as aero modeling. Now, let's understand what is aero modeling. Aero modeling is understanding flight through model aircrafts. Imagine building your own aeroplane. You switch on the remote control. The plane takes off smoothly, performs loops in the sky, and lands back safely. Isn't it interesting? This is the world of aero modeling, the science, art, and engineering of designing, building, and flying model aircrafts.
Why was aeromodeling needed? Aeromodeling was needed for several reasons, such as STEM education, design testing, and for competitive sports. Aeromodeling was also needed for people to understand aerodynamics, for new pilots to get pilot training, and for research and innovation.
We will see the evolution of aero modeling. The first phase takes place in the 1800s, where the early gliders were found. In 1903, an important point in the field of aero modeling was made. It was the Wright brothers' first flight. In 1930, model aircraft competition took place. Then, in the 1970s, radio control or RC aircraft came into existence. And in the 2000s, electric radio control aircraft were popular. Now, in the present time, first person view or FPV and autonomous aircraft are commonly found and used.
It's time to explain the main components of a model aircraft. First one, wings. They are located on both sides of the main body and help to generate lift, a force which is crucial for the takeoff and maintaining airtime in the sky. Imagine ailerons as a small strip near the wings, which help in the roll control of the plane. The propeller provides the thrust. A small brushless motor helps spin it at very high speeds. The fuselage, also known as the main body, acts as a foundation holding all these parts together and giving form to the plane. The tail with the rudder and elevator helps in dashing control. Some important inner parts of the model aircraft are as follows. ESC, also known as electronic speed control, helps in speed control. Battery provides the power to the plane, receives the radio signals from the pilot, servo motor helps smooth the surfaces, and the remote control takes in the pilot input.
Now, I'm going to explain the science behind flight. There are many forces that help an aircraft to fly in the air. They are lift, thrust, gravity, and drag. Lift. Lift is created by the wings and its airfoil shape. Drag. Drag is the opposite of thrust and it is what slows the aircraft down. And it is due to the backward air resistance. Thrust. Thrust is the forward force generated by the motor and the propeller. Gravity. Gravity is the downward force that helps an aircraft to land. Now, Ivan will be explaining how an RC aircraft works.
We are going to talk about how an RC aircraft works. First, the pilot input. The pilot gives the force it wants to give to the plane to make a change in speed or a change in action. Next, the transmit signal. The signal is transmitted from the remote control of the pilot to the receiver in the plane. Next, the receiver's command. The receiver commands the motor or the servo to move according to the driver's wish. Finally, the servos move. The information has reached the servo. It moves according to the pilot's wish. Now, the important point is that the pilot's command travel as radio waves within milliseconds. It allows for quick and sharp maneuvers.
It's time to talk about the applications of aero modeling. First one, aviation education. STEM education and flight schools worldwide nurture a students' aero modeling capacity and engineering capabilities. Solar and electric aviation. It's for longer flights over longer distances using clean energy which does not pollute our environment. E and autonomous flight. Imagine having a flight which follows our commands like magic. Well, that's exactly what AI and autonomous flight does. It also helps in swarm technology. Having a country which patrols its borders using drones and planes will surely be successful. Well, that's exactly what defense training does. Drone development helps in fields like delivery, agriculture, and surveillance drones. Also helps to make genius inventions and discoveries in the field of drones. FPV racing. FPV, also known as first-person view racing, makes the hobby of aero modeling more fun and competitive.
Now, I am going to explain the future innovations of aero modeling. Solar-powered plane. These are planes that run using the energy from the sun for conservation-related reasons. VTOL aircraft. VTOL stands for vertical takeoff and landing, and this is used for urban environments where vertical takeoff and landing are needed. Firefighting drones. These help in creating quicker responses to wildfires and help save more lives. Wildlife monitor. This helps to track endangered species of animals from the sky. Now we'll be ready to show a prototype made by Ivan.
It's a prototype that we had made. It's a Boeing 787 Air India type.
It's a commercial plane, which means it is a kind of plane that passengers travel upon to get across a country or an ocean. It is the kind of plane that you see in our everyday life from airports or different countries.
We made this airplane using paper, and we also put cotton inside the plane so that it doesn't compress. And we put glue to put the parts together. We also printed the paper to make it look like a Boeing 787.
Thank you.
Thank you.
That was a captivating journey into the world of aero modeling. Well done, team, for beautifully presenting your research and ideas. Now we invite our esteemed judges to share their questions and valuable insights on the presentation. Over to you, Tatiana, ma'am.
Okay. Farah. Have you built a model airplane from paper?
Yes, ma'am.
Yes, from paper. Did you use 3D modeling or 3D printing? Why you prefer?
I usually printed it. I printed it.
We printed the paper.
Printing with paper. Yeah, it's possible. I don't know. I think it's possible to print just with plastic, but you print with paper.
Yeah.
Yeah. And what kind of printer you used? Did you use some special printers?
Man, we
No,
just
it's a brothers printer.
the model out of normal paper. We just
On a
printed
paper.
paper to make to put the color and stuff. To put the color and the designs.
We only use the paper for like using the color. Like we put the printer to get the color only.
Okay. Okay,
I
I misunderstood. And could you try to use RS remote control to control your another players?
It's a still model.
Models. Yeah.
Not a working model. It's still model. It does not work. It's just
Yeah,
still
yes, I understand that it is model, but maybe you can use remote control for you can use it.
If we code the plane and put like enough stuff like useful stuff inside the plane, we can use remote controls.
Then we should
If
put
we
the propellers,
develop it.
servos, ESCs, motors, and other things, and battery, and code the plane properly to make it work with the remote.
Okay, all of us, all of you could work with remote control models. Yes.
And we didn't understand.
I couldn't hear.
No.
Excuse me, ma'am. Sorry for interrupting. Can you please, sorry for interrupting. Can you please repeat the question?
Do you all know how to fly a plane with remote control? Try to fly with remote control.
Yes, ma'am.
but you show some models with remote control, but not fly. It's
we did not understand it.
I don't know.
Yes, sorry to interrupt. So, students, what ma'am is trying to ask is whether why didn't you guys made a working model of airplane rather than creating a still one? You know how to fly a plane if you know all the components. Why did you go for a still model rather than a working
Ma'am, it
model?
will be harder to make and it will be more expensive and it will take a lot of time. That's why we opted to the still model.
Okay. Okay, thank you.
Thank you, Tatiana ma'am. Next, I would like to call Farah.
Thank you very much. And hugely another fantastic presentation. So huge commendations to this group as well, especially that you are in grade 7 and also quite young and just starting out with all this. So really good. It was a very exciting topic and your introduction was very exciting. I was gripped straight away. I really liked how you explained why aero modeling is needed and the historical timeline that you outlined. It was very inspiring to see because we've come from very humble flight beginnings from the Wright brothers to now space rockets flying off into space. So you really outlined that so well and really well done. And particularly as a science specialist myself, I loved that you explained the science and what happens in flight. So you have very good knowledge. Very well done. I learned something new from your presentation. I learned that there are solar powered planes. And while you were presenting, I was very quick Googling on my phone about solar powered planes. And I was very intrigued to hear that this is something that is happening. From your knowledge about solar power planes, my first question to you is, in your research, have you come across a challenge to having a plane that is solar powered? What could be a challenge that might make it difficult for aircraft to be solar powered?
I mean, it will be hard to fly during the night because there will be no sun to provide the power. And it will be kind of hard to put all the solar panels. It may be heavy and the flight cannot take off.
Yeah, and the aerodynamics won't allow the solar panels to be on top of the plane without reducing lift and thrust.
Yes, exactly. Did you want to add anything, Evan? Okay, so you're right. Basically, the whole prospect of getting a lot of weight, a lot of mass off the ground, solar panels will need to provide sufficient energy for that to happen. So that is a big challenge. At the moment, we have small, lightweight aircraft that are solar powered, but obviously not a commercial aircraft yet. But in the future, who knows? You might be the ones that design an actual jumbo liner that can take people across the world in a solar powered plane. So very interesting. And I think also when you mentioned in your PowerPoint about AI and autonomous flights, you missed an opportunity there to talk about flying cars and flying people, because that is also aero modeling as well. Have you come across that in your research? The flying cars, especially in countries like the United Arab Emirates and Dubai, they're very big in trying to be the first nation that release flying cars or have jetpacks for people to fly as well. So that's an interesting angle. If you haven't thought about it yet, as you take your projects further, you can think about that too. So you showed your prototype and you've explained to Judge Tatiana how you've built it. Really perfect looking model, by the way. The scaling and the features are very perfectly put together. So that's, again, well done from me. My second and final question to you, if you could improve your aircraft, that model that you've made, what would you change? Are you there? Did you hear my question?
No, ma'am. I could not hear.
Did you hear my question? Shall I repeat
No,
it?
no, I think you had like connection issues. I'm not sure. Maybe it's my connection. I don't know, but I couldn't
Okay,
hear.
maybe it could be. I will repeat my question. On your prototype model of your aircraft, if you could improve one thing, what would you improve?
I
would
would,
make it,
I would like
we
to
would make it
improve
more
the
durable.
I'll try to make it more bigger so it will be more easy. To make this and all it's very minute. So if I had a more bigger paper, I can make it very easy.
That's brilliant. Any other ideas, Michael or Aniket? Any ideas from you?
like we would like to make it an RC flight, but that'd be too expensive and it will take a long time to put together. That's why we opted for a still model one.
Michael?
We would like to make it out of plastic because right now, like it could easily tear on any. Yes, there is cotton inside it, but still, we need to make it more durable. So plastic would be a better option, but we couldn't make it because we don't have time and it would be too expensive.
We would
Very
also
good
like to
answer.
use stronger glue so that we can reinforce the parts together and prevent it from folding and breaking apart.
Excellent, thank you. And just inspired off a comment from Judge Tatiana just now, you could look at attaching a motor to the base of your plane model with a remote control and at least getting it to drive, maybe not fly straight away, but drive, because one small step leads to another small step, which leads to bigger outcomes. So that could be something else that you do. And thanks to Judge Tatiana for inspiring that thought process here as well. Thank you all. Very good luck today. Well done.
Thank you, ma'am.
Thank you, ma'am.
Thank you, judges, for your valuable questions and feedback. And once again, a big round of applause for our young innovators.
So now that our principal, Father Sabu, and our headmaster, Tom Sir, have joined the meeting, we would like them to address the meeting. Father, please.
Okay, can you hear me?
Yes, Father.
Okay, good evening, everyone. So I'm very happy that our students are attending one of the most relevant programs for inspiring our young innovators of New India. As we are aware, we are going through a changing phase of education in India. We have started our new education policy, and I see this program beautifully reflects the vision of our national education policy on education, which stresses on the 21st century skills, experiential learning, scientific temper, and technological awareness among our students. So it is quite relevant that we have, we are arranging such a big program. I sincerely appreciate the entire team for organizing such a wonderful events. Albert Einstein once said, the important thing is not to stop questioning. Not to stop questioning. So we'll have to question. Then only we get the answers. So let this program nurture the qualities of curiosity among our students. And I sincerely congratulate all our budding technologists, teachers, mentors, and our judges, Ms. Farah Khan and Tatiana. I hope I pronounced correctly your name. Okay. So thank you very much for your presence. And this is the education of new India, where our students are not merely preparing to face the future, but they are empowered to create the future. So I appreciate all the participants, and I sincerely appreciate the coordinators, especially our headmaster and the representatives of HowNWhy and all of you. Thank you very much. God bless you. Thank you.
Thank you, Father, for your motivating words. Now, Tom, sir, would you like to address the meeting too? Okay, so yes, heading on to our next presentation. Our next team takes us into the vibrant world of animation. From bringing stories to life to creating immersive visual experiences, animation is transforming the way we imagine and communicate ideas. Let's see what our young creators have discovered about this dynamic and expressive field. Please welcome Olivia Kate Nobi, Avantika, and Aduda Nair of Grade 7 presenting animation.
Good evening, everyone. Today, we are presenting an animation, a fascinating combination of art, technology, and storytelling. Animation allows us to bring ideas to life, communicate complex concepts, and create unforgettable experiences. Welcome to the enchanting realm of animation, to its humble beginnings to today's breathtaking digital creations. Animation has continuously pushed the boundaries of creativity and storytelling. Let us begin by understanding what animation really is.
Animation is the process of creating the illusion of movement by displaying a sequence of still images rapidly. This works because of persistence of vision, where our eyes briefly retain each image, making image appear motionful and smooth.
Today, animators use many powerful software tools like Adobe Animate and After Effects are widely used for 2D animation, while Blender and Autodesk Maya are popular for 3D animation. Tools like Houdini and Nuke are used for advanced visual effects and compositing.
Artificial intelligence is changing the animation industry. AI can generate concept art, automate repetitive tasks, and improve animation workflows. This helps creators save time and focus more on creativity while increasing production efficiency.
AI has both advantages and challenges. It makes animation faster, more affordable, and accessible to independent creators. However, also raises concerns about originality, copyright, ethical issues, and the future of jobs in the animation industry.
Animation comes in different styles. 2D animation uses flat drawings. 3D animation creates realistic digital characters. Stop motion uses physical objects. Rotoscoping traces live action footage. And motion graphics focuses on animated text and visual elements.
Creating an animation involves three main stages. Pre production includes planning, script writing, and storyboarding. Production is where the animation is created. And finally, post production adds visual effects, sound, editing, and rendering to produce the final result.
Successful animation follows 12 principles of animation developed by Disney animators Ollie Johnston and Frank Thomas. Principles such as squash and stretch, anticipation, and timing makes movements look natural, expressive, and believable.
Animation technology has advanced significantly. Real-time rendering, motion capture, cloud rendering, and realistic simulations of air, water, and smoke have made modern animation more detailed, immersive, and visually stunning.
Animation has a rich history. It began with optical devices like the zoetrope, evolved into hand drawn animated films, and later transformed through computer generated imagery, also known as CGI, which revolutionized modern filmmaking.
Animation is a universal language. It entertains people of all ages, supports education, promotes cultural exchange, and communicates ideas beyond language barriers, making it one of the most influential forms of visual storytelling.
Animation is also used beyond entertainment. It helps doctors explain medical procedures, architects present buildings, designs, engineers create simulations, educators simplify learning, and businesses communicate information effectively.
Despite its many benefits, animation also has challenges. Excessive screen time may affect attention spans, and the industry often faces tight deadlines, long working hours, and concerns about stereotypes and the ethical use of AI.
Some milestones in animation include Snow White and the Seven Dwarfs, the first successful animated feature film, Toy Story, the first fully CGI feature film, Nisa 2, a global office success, and Demon Slayer Infinity Castle, known for its exceptional animation quality.
This is a basic ball animation created using 54 frames. Each frame shows the ball in a slightly different position. When these frames are played quickly one after another, they create the illusion that the ball is moving. This happens because of the concept of the persistence of vision, where our eyes briefly retain each image, making the motion appear smoothly.
This is an AI generated animation prototype made by Gemini 3.1 Pro Advanced.
In conclusion, animation has evolved from simple moving images into a powerful tool for storytelling, education, communication, and innovation. As technology continues to grow, animation will play an even greater role in shaping the future. Thank you for your time and attention. We are now ready for any questions.
That was a delightful journey into the world of animation. Well done to the team for creatively presenting your ideas and bringing them to life. Now we invite our esteemed judges to share their questions and valuable insights on the presentation. Over to you, Farah.
Thank you so much, all of you. You spoke so well and presented fluidly. That was a really excellent presentation. Well done to you all. You should be very proud of your efforts today. I really liked that you started off the presentation by discussing what animation is, and then you focused on AI in animation, and you outlined so much regarding the production phases, which was so interesting to hear about. Thank you so much for that. I like that you all spoke. Very good team. You obviously have been working on this together, which is really fantastic. So well done to all of you. I have a couple of questions. My first question is about animation and the use of AI in animation. I was paying a lot of attention to your prototypes. Very impressive that you showed not one, but two prototypes just there. Were there any challenges when you were developing that? What kind of obstacles did you have to overcome to achieve that end result?
It was actually pretty simple. I used an app for it and I hand drew 54 for the first prototype. I hand drew the prototype.
Wow. Did you experience any challenges at all?
I don't think so.
Do you think that the ball bouncing was accurately portrayed, or was it a bit glitchy?
I guess it might have been a bit glitchy, but yeah.
So that counts as a challenge, that AI is amazing and doing so many amazing things, but AI is not yet able to do what a human can do, not in the true sense. Soon it will be, it will bypass even human ability. But right now, that human factor is still very important in AI development. especially if the ethics of AI, using it in the right way for the right reasons, all of that has to be considered. So humans have to be very much part of that. In terms of animations, I like the second one as well that you showed. Can you tell me more about how that was produced?
Well, we asked that to Gemini to generate it for us.
Very nice. Thank you. That was really good. And my second question is, if you could get animation, whether it's just animation or AI in animation, to help explain something, a topic, maybe a topic that you're learning at school, can you think of a topic that you think this would be a perfect tool to use to explain this? What kind of topic could be explained?
I think we could use it for like learning history, like, for the past, to learn about the empires.
That's an excellent answer, Olivia. Thank you. Advita or Avantika, do you have any answers that you think in school animation could help us to learn better?
Same as hers, and plus for science, like for like certain processes, also you could generate the music animation in AI.
Yes, in science, we can explain the solar system. We can go inside a cell and show what's happening in a human body cell. There's so much we can do. Absolutely. And Avantika, your turn.
I believe motion graphics could be used for studying like any language subjects or anything more interesting and engaging.
Precisely. The human mind learns better when we are engaged. So animation is such a fantastic way in education to help engage young minds like yourself so you can learn so much more. But remember that animation and AI is not yet superior to the human mind. So keep your minds above all else, keep them nourished and stimulated. Well done, all of you. That was wonderful. You handled the questions really well. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Over to you, Tatiana, ma'am.
And my question is about in your second prototype, you used anime style. Why did you decide, and who maybe from Olivia, Advita, or Avantuika? Excuse me for my mistakes, decide to give this type of animation? Why anime?
Anime style is usually more detailed and it's more practical to audience.
Okay. And maybe you have favorite animation film, and you say what film, what kind of film you like.
Demon Slayer anime.
Demon Slayer.
Anime?
Yeah, Demon Slayer.
Yes.
Okay. And Olivia?
For animes, I would say Apothecary Diaries. I really like that.
Okay, thank you. Thank you.
Thank you, ma'am.
Thank you, judges, for your valuable questions and feedback. And once again, a big round of applause for our young innovators.
And now it's time for our second quiz to bring our YouTube audience back into the action. As part of our 6 exciting questions across these 2 days, here comes your second chance. The second question. Remember, the winner will be selected from those who answers all 6 questions correctly. You can participate by scanning the QR code on your screen or by clicking the link shared in the chat box. You'll have just 1 minute to submit your answers, so stay quick and focused. Get ready once again, keep your phones handy, and let's see who gets this one right. The question is, which sensor is commonly used to detect distance using sound waves? May I repeat? Which sensor is commonly used to detect the distance using sound waves? A little pause, a little thought, and that's all it takes. This is where observation meets intuition. Time is ticking. Time's up. Keep watching. We'll reveal the winners later. Now, let's get into the project presentations back. Over to you, Safania.
Our fourth team takes us into the innovative world of 3D printing. From turning digital designs into real world objects to revolutionizing fields such as medicine, manufacturing, and design, 3D printing is reshaping how we create and build. Let's see what our young innovators have discovered about this groundbreaking technology. Please welcome Vivan Kurup, Stephen Padaval, and Adarsh Santosh of Grade 6 presenting 3D printing.
I am Stephen Padavil.
And I am Vivan Korup.
I am Adarsh Santosh.
And we are the 3D printing team.
Today, we are going to talk about 3D printing, building 3D objects one layer at a time. What is a 3D printer? A 3D printer builds 3D objects and the output is 3D. It is not on paper. An ordinary printer only puts ink on flat paper and the output is 2D. It works by adding material layer upon layer until the entire object is finished. You can use it by your own 3D printer. That means a prosthetic hand, a replacement gear, or spare part can be made on demand without a factory. The three main types: FDM, SLS, and SLA. FDM, fused deposition modeling. It works like a robotic hot glue gun. And then a plastic thread is melted and squeezed out line by line, layer by layer. SLS, selective laser sintering, which is a high powered laser which melts and fuses tiny grains of plastic or metal powder together. It is used in labs. SLA, stereolithography, which is a UV light which hardens liquid resin one thin layer at a time, which are used in factories. Inside the 3D printer, which is also known as inside the hot end. First, the feeder wheels. Grip the solid filament and push it steadily down. If they slip, nothing prints. And next, heatsink and fan. Keep the top half cold so the filament stays hard until the last moment. Heat break. A thermowall that flips the plastic from solid to a molten in a split second. Heater block. A mini oven melts the plastic and a thermistor keeps the heat perfectly steady. If you're asking what a thermistor is, it's an object which keeps the heat absolutely perfectly steady. And also, it does not let the nozzle also overmelt. Nozzle, which forces the melt out as an ultra thin layer thread that draws each layer.
How it works? 5 steps. From an object in your screen to an object in your hand. First, we design it in a 3D model software or download it ready made. Then, our software slices the model into hundreds and thousands of very thin layers. Tools inside the 3D printer heats the filament into a soft gooey form. The nozzle squeezes the goo out, forming the object. The object cools very fast, so we can get our object with maximum efficiency. What it prints with? There are 4 main filaments: PLA, ABS, resin, and metal. PLA is convex plastic. It's easy, cheap, but a bit weak. It's the most common filament. ABS, it's tough and heat resistant. It's used in car parts. Resin, liquid cured by UV light. It's fine detail but weak. Metal, titanium and steel powders fused together by laser. Herbalism. 3 names cover most of the market. Bambi Lab is fast, quiet, and the most beginner friendly one. Prusa is a reliable endlessly repairable, and has a very large community behind it. Stratasys, large professional machines used in real factories to make production parts. Our prototype. This is my prototype. The text dream sits on top in thick actual letters. There are bevel corners and a small hole for the chain. The software was Blender and the filament is PLA.
My keychain is shaped like a heart and has the text car on top of it. It is meant for tourists, and the software I used was Tinkercad, and the device I used was mobile.
My 3D model is a 3D printed picture with a 3D printed rules written on top of it. It has a start label on it, and there's a hole right next to it for a keychain to fit right in. I used the system Tinkercad to make it, and the device I used was a PC.
Where it is used: medical, artificial lips and dental models, automobile, carpets and fast prototypes, construction, printed households with and architectural models, space, rocket engine parts and satellite components, education, school projects and hands-on learning models, food, printed chocolate, pasta and meat.
Next, we will show a live presentation. This is Tinkercad, the software where it's a 3D modeling CAD designing software. You can drag and drop the shapes from here and deform it however you like. This is Bamboo Studio. This is a slicing software. Here I have a model. If I press this button, it will slice the model into very thin layers.
What comes next? In this next it could be happening. In 2030, they are going to print house in matter of days. In 2035, they are going to print food to chocolate to meat. In 2040, they are going to print human organs. And in 2045, they are going to print spare parts in the orbit. There are two types of FTA printers, such as the Besting and Excico. A Bamble A1 Mini and a Clarity 3 they are examples of Bestinger. And by comparing by the speed, it is slow and Excico. Bamboo A1, Bamboo Exxon Carbon and Clarity K1 are examples. They are fast by comparing the Bestinger. Creating changes how we make things. It is already fast, accurate, and very useful to us. Machine, industry, space, and only the limits are speed and materials. All these are going to go down, and we will have faster things. And we will leave it out. The future is being printed right now, and we are part of it. Thank you.
That was an insightful journey into the world of 3D printing. Well done, team, for clearly presenting your research and creative ideas. Now we invite our esteemed judges to share their questions and valuable insights on the presentation. Over to you, Farah ma'am.
Thank you so much, everybody. What a wonderful presentation you've all put together, and such depth of knowledge demonstrated about 3D printing. I really like that you started your presentation by introducing to us what 3D printing is and how it works, because I think it is a very difficult thing to explain. How can you explain to somebody that you can make a screwdriver, a chocolate, a house in the future? Like, it's very hard to explain, and you did that really well. And all of you spoke, and you're a very good team, good teamwork there as well. The quality of your presentation was outstanding. You had the right animations, the right wording, everything was formatted really well. So huge well done to all of you for your efforts today. I paid a lot of attention immediately when you said about 2030, it might be possible to build a house in a number of days. We're already approaching the end of 2026. So 2030 is like 3 years away. In the research that you were doing, how feasible do you think that timeline is? Do you think we really will get to that stage so quickly regarding building a house in a few days using 3D printing?
I think that we could reach there pretty quickly because currently we are actually printing houses right now. And even entire neighborhoods are being built using concrete and 3D printers. They are larger than the usual ones. They are extremely big, but real companies are really printing houses for people.
Very good answer. Well done. And my second question to you is if you could 3D print something for yourself, what would it be and why would you choose that item? So if all of you can answer that question.
First, I'll go. I think I would thought about this. Like others shared around 2045, we'll be printing the patient's own we'll be using the patient's own cells to create their organs, which I found particularly the most interesting thing. Like I think about it more, but I couldn't think of it. Like it's so hard to use the same cells to make. So I want to try to make these 3D printers print organs and help people which are need of them. I actually want to become a doctor also. So yeah.
Very good.
So currently, if I was able to get a 3D printer in my own hands, which I was able to get because of government, sir, I would probably print something that is actually needed in my house right now. For example, if something is broken, for example, if a minifigure is missing an arm or a leg, I could easily measure it and print it and fix it. For so that I can fix a lot of things in my house that are like half broken. So which is very helpful. The problem with 3D printer is that it's a bit expensive and soon it will be a lot more cheaper, which is very exciting to hear.
Very
And
good answer.
and for me, I think like very useful things for me, like a phone holder, which I can hold my phone and put it there, and it will be useful. Right now, I'm using one, but like it's nearly done. So like, yeah.
That's excellent. All of you, Vivan, Stephen, Adarsh, really good answers. You've clearly researched 3D printing because I kind of put some surprise questions in and you've answered them with confidence. So I was testing your background knowledge. It's really excellent. Well done. Can you build me a 3D house with your
That will take a
3D
very long
printer?
time.
It will take 2030. You said, you promised 2030. Can you just also show your prototype? I kind of missed that because it went a bit fast. Can I hear more about your prototype?
This one.
First, we
Oh,
created this.
that's excellent. What have you all made? What have you made, Vivan? You've made a ruler.
I actually made a keychain which has a
Ah,
hole right here, and also the name 3D printing rules, and that. And also we made an additional model for the FIFA World Cup. You already know it's like a very big fuss about. So we made two diamond. You will not be able to see it's hard, but we made two diamonds. The system which Steven showed, Tinkercad. We used two diamonds and flattened them to make them look like football. We placed two, one here and one here, and in the between, it is written FIFA.
that's fantastic. Which team were you supporting in FIFA for the
I
World
was
Cup?
particularly supporting Portugal, but uh, like they got out.
They did, they did. And Stephen, what did you build?
This is also actually keychain. When Sa said that we needed a prototype, I was the first one to build it. And since it was so fun and particularly interesting, all of them followed. And in total, we made 4 prototypes. We all made one uh, alone, and the FIFA one we made together at school, which was really fun. And this is actually also a keychain. Since I said we need something simple and easy to print. Now you cannot really see it clearly. That's why I added an image in the PPT about this.
Very nice indeed. And lastly, Adarsh, what did you make?
I made a keychain about Goa. It's written here.
Ah, is that a heart for your mum?
Sadly,
Or
no, but
someone else? For your
I
mum.
guess it could be.
Okay, thank you. All right, thank you very much. You've answered my questions. I really enjoyed how you engaged the audience. Very well done.
Thanks.
Thank you, ma'am.
Thank you, ma'am.
And I Thank you for your presentation. And I want to ask you, what program do you use for 3D modeling? I have two programs, but V1, what
Yeah.
kind of program you use?
We Stephen actually used Blender for this, and me and Adarsh used Tinkercad for this. Tinkercad is much more easier, but in Blender, like we have to like particularly. I don't know about that. Stephen can talk about it. I know that he knows a lot about it.
Blender is actually a lot more harder than Tinkercad. I would use Tinkercad, but I have a bit of experience with Blender, so it was easier to navigate. And Tinkercad is easy for simple models, and Blender is very versatile. It can make animations and very complex 3D models.
Thank you.
Thank you, judges, for your valuable questions and feedback. And once again, a big round of applause for our young innovators.
Our next team takes us into the connected world of Internet of Things IoT. From smart homes to connected cities, IoT is transforming everyday objects into intelligent systems that communicate and make lives easier. Let's explore what our young innovators have discovered about this powerful and ever-growing technology. Please welcome Lakshmi S, my co-anchor here, Rionalis Latish, and Jewel Bobbin of grade 8 presenting Internet of Things IoT. Jill, your mic is muted.
Hello. Dobry wieczór. Hope I was correct on that. Good evening, everyone. I am Jewel, and today my teammates Riona, Lakshmi, and I are going to present on the IoT revolution and the smart LED. In today's world, many everyday devices can connect to the internet and communicate with each other. This technology is called the Internet of Things, or IoT. We'll explain what IoT is, its benefits and challenges, and finally show how it's used in our smart LED project. Here's what we'll be covering today. First, we'll understand the basics of IoT and how it works. Next, we'll discuss both the positive and the negative impacts of IoT in our daily lives. Finally, we'll introduce our smart LED project and explain how it uses IoT concepts. Let's begin with the first part of our presentation, the core of IoT. Before we look at examples, it's important to understand what IoT actually is and why it has become such an important technology in today's world. IoT stands for Internet of Things. It refers to physical objects such as light, sensors, home appliances, or even vehicles that are connected to the internet. These devices collect information using sensors, share that information online, and can communicate with each other automatically without requiring constant human control. This allows devices to make smart decisions and improve convenience in everyday life. Every IoT system works in three basic steps. First is sensing, where sensors collect information such as temperature, light, or movement. Second is transmission, where the collected data is sent over the internet. Third is processing, where the data is analyzed so that the device can take the appropriate action. Now I'll hand over to Riona, who will explain how IoT works in real life and discuss both its advantages and challenges.
Thank you, Jill. An IoT system begins when sensors collect information from the surroundings. This information is sent over the internet to a cloud server or computer where it is analyzed. Based on the results, the device performs an action, such as switching on a light or sending an alert. This entire process happens automatically and almost instantly. Now let's look at the positive and negative sides of IoT technology, also known as tech duality. Like every invention, IoT has many advantages but also some challenges. Understanding both sides help us use technology wisely and responsibly. IoT is used in many places around us. It is used in smart homes, hospitals, industries, agriculture, transportation, and in many other areas. In homes, it controls lights, fans, and security systems. In hospitals, it helps doctors monitor patients. In agriculture, it helps farmers check soil moisture and water crops efficiently. IoT help offers many important benefits. It improves efficiency by automating everyday tasks. It provides greater comfort because devices can adjust automatically to our needs. IoT also helps reduce energy waste, saves time, lowers maintenance costs, and increases safety by detecting problems before they become serious. Although IoT has many benefits, it also has some risks. Since devices collect personal information, protecting data privacy is very important. Hackers may also try to attack connected devices if they're not properly secured. Another concern is electronic waste because old devices are often replaced with newer ones. Therefore, IoT should always be developed and used responsibly. Now, I invite Lakshmi to present the final part of our presentation.
Thank you, Rihanna. IoT has grown rapidly over the last few years and is now becoming a part of our everyday lives. Most schools, homes, hospitals, and industries are adopting smart technologies. Experts predict that over 75 billion connected devices will exist in the coming years. IoT will create smarter cities, safer transportation, better healthcare, and help reduce energy consumption. Now, let's move on to our project, the Smart LED. This project demonstrates how IoT concepts can be applied to control light intelligently. So let's
Hello guys, so today we'll be showing our prototype, the Smart LED HCS. We have used Blink, which is an IoT platform, and we have created a template and we added the data stream to it, and we created a variable called V0. When V0 is equal to 1, the bulb glows, and when V0 is equal to 0, the bulb turns off. We have added the code to the ESP32 and we have powered it using the computer, and when the bulb turns on, the values are shown on the serial monitor.
Smart LED systems can be controlled automatically or remotely. It shows how connected devices can improve convenience while saving energy. This is a simple example of how IoT can be used in everyday life. Thank you all for listening to our presentation. We hope you enjoyed learning about the Internet of Things and our Smart LED project. We will now be happy to answer any questions you may have.
That was an insightful journey into the world of IoT. Well done to the team for clearly presenting your research and creative ideas. Now we invite our esteemed judges to share their questions and valuable insights on the presentation. Now I invite Farah ma'am to share her questions and valuable insights.
Okay, thank you. That was wonderful. Another great presentation. I'm really enjoying this entire event today. All of the groups so far, and I know we've got one more to go after you, but all of the groups so far are just outstanding. I'm learning so many new things, and I'm an experienced educator, and you're teaching me so many new things. So thank you, all three girls here, for your wonderful presentation. It was very insightful, very interesting indeed. And clearly you are working well as a team, all taking turns with your research and your presentation and communication. It's really good. Could you tell us a bit more about your prototype?
Ma'am, we made it using an IoT platform called Blink. It is more accessible and it is usually commonly used. And we added templates to it, and we added the data stream, and we created a variable called V0. So I said in the video, when V0 turns 0, the bulb will turn on, and when V0 is equal to 1, the bulb will turn off. And we added all these data into the ESP32, and we connected the ESP32 to our laptop as to power it. And when we turn it off, the values will be shown on the serial monitor. We have used the app called Arduino IDE for programming this.
That's a very difficult thing to achieve. So that's really impressive. Were there any challenges when you were putting that together?
We actually got to know a lot about apps and coding apps that we haven't seen before. Like, it was my first time working on Blink and Arduino IDE. So it was a very informative topic for us.
Wow, very impressive. Well done. And my main question to you is, in your home, if you could make one thing smart, what would you make smart? Jill, Riona, Lakshmi, if you take turns to answer that question. What would you make smart in your home?
Well, I mean, IoT is actually a pretty I never knew that it would be so much involved in our life. So if there was one thing that I'd like to connect to this whole entire IoT platform, I think it would be like kitchen appliances. So first it would be if when you first you would enter the kitchen, then suddenly if you want to boil some water, you just put it on the stove and automatically starts and all that stuff. Then thermostats also really cool. I would I would even add a fun little disco feature. So when you say disco, it starts. Well, it's just a fun little quirk I have, but it'll be really cool if I could connect my whole entire every home appliance to one thing. And yeah, that's basically my answer. Lakshmi, you have anything else?
I think that's a really good answer. The kitchen is the heart of the home. And so if we can make that run efficiently and successfully, that'd be brilliant. That's a really good answer, Riona. Joel and Lakshmi?
I actually have an idea. We could use the water management system in our house. It could detect the water level in our tank, and if it's too low, it could send a message to our phone to turn the motor on. And if when we turn the motor on, if the water is overflowing and if it comes to a particular limit that we should stop it, it can send us a message.
Very
So that
important,
it will.
especially in India. Sorry, you were saying, do you want to finish your answer?
So it will typically reduce water wastage, right?
That's an excellent answer, thinking about environmental consciousness and sustainability. And in a country like India, water is a very big issue. So that's a really smart answer. Thank you. And Joel?
If I could get out of the house at a certain time, all of the lights and switches could turn off at the same time, so I don't have to worry about turning off a particular thing. When I leave the house, if I leave the house, I'll usually be scared, is the gas stove on or something like that. So if it all turns off at the same time, then I don't have to worry about it and run back into the house.
Very, very good ideas. And I hope that you all three go on to pursue further and make living smart for everybody, especially young females like yourselves who should be focusing your talents on your work and your careers because you are very smart minds. So I'm really impressed. Thank you so much for your presentation.
Next, I would like to invite, so sorry ma'am, is your questions over, Farah ma'am? Okay.
I used Blink for my students use Blink in projects, and I don't hear about what kind of microchip you use, Arduino or something else in your project.
We use
What type of-
ESP32.
What?
ESP32.
ESP. Okay, ESP. Okay, it's very interesting. One project was about turn off Christmas tree through a phone. It's put in two. And my question is about what device would be useful at school. You said about home, but at school, what kind of device it's very useful at school?
I think a sound sensing IoT device could be useful. In a particular classroom, if the noise level is going above a particular point, it could directly send a message to the class teacher or the headmaster so that they can control it and maintain the discipline.
Thank you. And Jewel?
I think that if you sense the amount of disturbance or when the students are getting tired of a singular subject, it could send the the message to the teacher, and they could change the way of teaching
which could make the kids engaging more on the
Okay.
topic.
And Riona?
Well, these two almost covered all my answers, but I think it would have been really cool if the atmosphere would feel nice and cozy, so everyone feels comfortable, and it'll also be easy to concentrate in class. So I think that's a good point I'd like to add.
Thank you.
Just as an add-on, because I do teach, it is the students' responsibility to concentrate in class, young ladies. Teachers don't need sensors telling them, entertain your students, engage them better. It's your responsibility to engage. Anyway, that was fun answers. Thank you.
Thank you, judges, for your valuable questions and feedback. And once again, a big round of applause for our young innovators. And now it's time to bring our YouTube audience back into the action with quiz question 3. We are halfway through our 6 questions challenge. So if you've been answering all along, this is your chance to keep your winning streak alive. Scan the QR code on your screen or click the link in the chat box to participate. You have a maximum of 1 minute to submit your answer. So get ready. Let's see who gets question 3 right. So the third question is, which technology allows computers to identify objects in images? May I repeat the third question? Which technology allows computers to identify objects in images? So I think most of you might have an answer. So if you do have an answer, make sure to submit it because an next exciting prize is waiting for you. The third question is again, which technology allows computers to identify objects in images? So time's ticking. Please submit your answers fast. All right. Time's up. So let's see who gets this one right. And now it's time to head back into our project presentations. Over to you, Lakshmi.
Thank you, Shreya. Our next team takes us into the fascinating world of biotechnology. From advancing healthcare to improving agriculture and solving real world challenges, biotechnology is shaping the future through science and innovation. Let's discover what our young researchers have explored in this dynamic and impactful field. Please welcome Lana Mary, Abel Binu, and Devna Kale of Grade 8 presenting biotechnology.
What if the cure for the next deadly disease is hidden in a tiny cell? This isn't science fiction, it's biotechnology. Today, we are here to show you how biotechnology is transforming our lives and shaping the future. So, what is biotechnology? Biotechnology is the process of using living organisms, cells, or biological process together with technology to develop medicines, improve agriculture, and create useful products that benefit our everyday lives.
Before biotechnology, many diseases had no cure. Medicines took years to develop. Crop failures caused food shortages, and scientists had very limited tools to understand life. Today, biotechnology has completely transformed our world. In medicine, it helps produce life-saving vaccines, insulin, antibiotics, and advanced treatments like gene editing. In agriculture, it develops crops that produce higher yields and resist pests, diseases, and drought. In environmental protection, biotechnology helps clean polluted water, manage waste, and produce renewable sources of energy.
The journey of biotechnology. In ancient times, people found out the fermentation of bread, cheese, and yogurt. In 1865, Gregor Johann Mendel finds genetics using an experiment with pea plants. In 1953, Francis Crick and James D. Watson finds DNA structure. Then they cloned mammals and it was a female sheep named Dolly, and it was the first ever mammal to be cloned using an adult mammal's cell. In, in today's world, we use gene editing technology to edit specific areas of our DNA as a treatment for many diseases.
Components of biotechnology. Microorganisms. Microbes like bacteria and yeast are used to produce medicines, food, and other useful products. Enzymes speed up biological reactions, making many industrial processes faster and more efficient. Genetical engineering. Genetical engineering changes an organism's DNA to give it useful traits. Cell culture. Cell culture grows cells in a controlled environment for research and medicines.
So how does biotechnology works? First, scientists identify a problem. Next, they study the living organism and their DNA. After careful research and testing, they develop solutions that improve our health, agriculture, industries, and the environment.
Which all factors do we use biotechnology in? We use biotechnology in agriculture, healthcare, pharmaceuticals, industrial, genetical engineering, and forensic science. Biotech industry leaders Pfizer and Moderna. Pfizer is a pharmaceutical giant, while Moderna is a small biotechnology company. These companies are known for developing the COVID-19 vaccine using mRNA technology. Amgen and Biocon. Amgen is a US based company, while Biocon is an Indian based company. Biocon usually supports Amgen in making new medicines. The Serum Institute of India was founded by Cyrus Poonawalla in 1966. They started off by developing immunobiologicals and now is known for developing COVID-19 vaccine. Ginkgo and Novartis. Competitors yet partners, Ginkgo is known for its R&D services, while Novartis is known for its microorganisms research.
The advantages of biotechnology. Biotechnology improves health with better medicines, increases food production, protects the environment, and benefits industries. But there are some environmental risks. It can raise ethical concerns. It can be costly. It could be technically demanding and can be misused if not properly regulated.
Finally, let's look into the future. The future of biotechnology is full of exciting possibilities. Scientists start developing medicines tailored to each person's DNA, lab grown organs for transplantation, advanced gene editing technologies to treat inherited diseases, and climate resilient crops to ensure food security. This is two of our ideas. So it's BioShield pots and BioGuard drones. So the BioShield pots go into the ocean. It contains bacteria and it goes into the ocean and it absorbs harmful pollutants from the ocean and comes back.
The biotechnology is water filter. It is used for cleaning dirty water with three filtration methods.
It is fantastic. The water passes to the biological filter. The microorganisms senses plastic so polluted and break down organisms. The second stage, the water goes to the cycle corpus and
the third stage, the water flows to charcoal, which reduces bad odor, color, and reduces some bad chemicals.
Finally, water is collected after passing three different stages. This prototype fully contains biology, but we need to use technology to use agri-nodes, sensors, or LED busters, check the water levels, and monitor the water quality, and also alert if the water is unsafe. Thank you.
In the end, who knows, the life changing development can be created by a person who might be sitting in this room. I would like to conclude this with a quote. The greatest discoveries begin with a single question: what if? And biotechnology is our answer to it. Let us continue to imagine, explore, and innovate because the future belongs to ones who use science to improve life. And I would like to thank the judges teachers, and all the participants for listening to our presentation. Thank you.
That was an insightful journey into the world of biotechnology. Well done to the team for thoughtfully presenting your research and ideas. Now we invite Satyana ma'am to share her questions and valuable insights on the presentation.
Thank you for your presentation. And my question is about your prototype. How did you evaluate the quality of your prototype, the quality of water?
Actually, this prototype is actually based only on biology, because the things we had limitations to add technology to it. But if we add technology, we could use water level sensors and water quality to check the water quality and alert if it's unsafe.
Okay, and another question. Now we use artificial intelligence for many purpose. And for your opinion, can AI help in advanced biotechnologies? And
AI
how?
is, yeah, AI is a great aspect in biotechnology because we need AI to find many like treatments and all. And plus, AI can detect many diseases faster than humans can detect with the older devices.
Okay, and Devna?
My idea is that we can also use AI like to create organs, like 3D printed organs, like that is especially tailored to each peasant's DNA, so that like some organs may get rejected. Like not all organs are accepted by the body, so some organs may get rejected. But if we use AI, we can make it more efficient. Like the chances of rejection is lesser.
Okay, thank you. And Lena?
I think AI could improve a lot of diseases. Like it can detect diseases faster, like cure the diseases, like vaccines. These are all AI generated. So if AI is advancing more and more these days, so we could use AI to do a lot of things to a single organism or a cell.
Thank you.
Thank you, ma'am.
Thank you very much, students. That was a very, very excellent and exciting presentation to watch. You've clearly gone into depth with your research, so you know a lot about the biotechnology. I especially like that you all took turns to speak and you're a very good team. So teamwork is the running trend in all the presentations today. All of the teams, including your good selves, are working very well, very cohesively together. And that's so important in any STEM work that we do, that we are able to be good team players. And I really like that you also outlined the before versus after. So straight away, very early in your presentation, you were able to signify the important developments and successes of biotechnology. And it was very eye-opening to see what a difference it has made to our quality of lives globally. The components that you outlined, microorganisms, enzymes, genetic engineering, and cell culture, these are very crucial components to biotechnology. And you've now, through your questions with Judge Tatiana, implemented some answers regarding AI and biotechnology, because that definitely is, I think, the direction biotech is heading in the very near future. I wanted to just ask you about your own, and you're allowed to make these personal opinions. They don't have to be your own researched opinions. It can be what you have now personally discovered following your research. What are your own opinions about ethics of biotechnology, especially in things like the genetic engineering aspect? What do you think about the ethics of that? Is there anything we should be worried about? Anything we should consider? What is your opinion on that, please?
Very good question, ma'am. If we consider biotechnology is a very useful tool for us, but when we create a new product, we have to test it on a living organism. So if we test it on an animal, it could go into the wildlife, and can it be inherited? So these are some concerns that comes into our mind about biotechnology while we are searching on it. I think Abel would like to add up some.
Yeah, I would like to add that people are worried to consume those GM crops, genetically modified crops. So they might think it might give a side effect after consuming those crops and food items. So that's one ethical concern that I think that many people worry about. Yeah.
I would also like to add a point. I just said this point about organ rejection. That's one point. Like so many organs. Even though the chances are more, like if we use AI, if we use biotechnology, but that's still a concern that people are just still concerned about it. Like they don't fully trust the process. But we have yeah, that's it.
Do you think the concerns are valid?
Yes, the concerns are valid. So if we clear cut it and put a red alert on all of the ethics, we could just improve the biotechnology in a very beautiful way.
Yeah. What might in the future help to alleviate the public concerns? How can we convince the public that biotechnology is something not to be concerned about?
So we can
Everything happens by experience. So first, we take a person who's actually not concerned and is really optimistic about this. So, and if that person's if that person has a disease or something that is a deadly disease or any kind of disease, we can treat it. And by setting an example like that, people will notice it, and we can make the people be show the people that biotechnology is actually pretty good and it's really good for us.
Did you want to say something, Abel?
Yeah, so we can show the test results to people. Like there might be some plants that might be harmful for us to consume before using biotechnology, but after modifying it, it might be good for our health. So after showing the before results and after results, we can like convince the people to use biotechnology and consume crops like that.
Thank you. Lena, anything you want to add?
No, ma'am, they perfectly described it. I think
actually have.
we should all support biotechnology, understand the advantages and disadvantages, and help biotechnology rise upwards.
I think with biotechnology, you've summarized it really well in all your presentation and the answers to both myself and Judge Tatiana just now as well, is that because it's to do with, a lot of it is to do with genetics. So people will be more skeptical and more worried about it. And the one thing that you have managed to successfully explain is that the way to alter public perception is through evidence, because all good scientists will gather evidence and then present that. So then the more evidence we can gather over a good number of years, people will then start to realize that maybe it's not so bad. But there are still ethics to consider. So as long as young minds, we're keeping those at the back of our minds, that there are still ethics and there are certain boundaries we have to be very mindful of, then biotechnology will be a very advantageous industry for the future. Thank you so much for your presentation. Well done.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, judges, for your valuable questions and feedback. And once again, a big round of applause for our young innovators. We witnessed 6 wonderful projects today, each bringing a unique idea and perspective to the stage. Now we will be delighted to hear from our esteemed judges. I would like to invite our esteemed judges to share a few words and feedback on today's presentation. We will be grateful for your valuable observations and suggestions.
Judge Tatiana, did you want to speak first?
It was very interesting experience for me and very interesting to know something new about India. It's in Finland now, summer and children not at school. And very interesting. It's in India. They are studying now. It's difficult. Time is difficult. Very interesting. All projects was very good, and students knew something new when they prepare with these projects. It's all about new technologies, and we talk a little about artificial intelligence. Very it's a buzzword now, but it's very important that students now use them for animation, for other projects, for 3D modeling, and all was very interesting. And we continue on Wednesday. I think it will be good too. Thank you.
Thank you. And just to second everything that Judge Tatiana has said, I'm very big on STEM, and I have been working in STEM education for now 25 years. And the presentations I have seen today are very high level. I am very impressed, especially because we have such young students from year 6 to year 8. It's brilliant. What's impressed me the most is that you've all been exploring very different technologies, and you've been really getting into depth and learning these technologies as well. And what you'll notice is that the more time you spend looking into these particular themes, those themes themselves are evolving at the same time as well, because progress is happening, and it's happening very fast. I am so impressed at the teamwork that I've seen and the prototypes that I've seen. Considering all the facilities that are available to you, I believe you have surpassed what you could achieve. You've done very well, every single team today. And the one thing that I would like to also encourage more is keep asking questions. Science is fantastic. I'm a scientist at heart, and I work in science, and it's absolutely brilliant, but we must keep asking questions and not just being excited and trusting something because it's just been made. Always look at what's the con. If that's the pro, what's the con, and go with that. And in the future, what will happen is 97% of the population globally will be tech users, but 3% will be the tech programmers and the tech controllers. And I am so encouraged to see such great, wholesome minds on this event today that I hope you are those 3%, because the world needs good, positive, nourished minds like yourselves to be running the tech. And so do pursue that, do take that further. Well done to everybody. And a big thank you for allowing this platform and for inviting me to be a judge today as well, to HowNWhy, to CPS, to all the pupils for welcoming me today as well. It's been a fantastic event. I really enjoyed it, and I'm also looking forward to Wednesday as well. Thank you.
Thank you, ma'am, for your valuable words and encouragement.
And with that, we come to the end of day one. We've seen 6 amazing projects today, but the excitement just doesn't stop here. Join us again tomorrow at the same time as our next 5 teams take the stage with their innovative ideas. Until then, keep exploring, keep innovating, and keep rocking. Good night, and see you all on the 12th of August.